Hello, my name is Sudhir Krishnan and I am Director of Wireline NFV Product Line Management. Today, we'll be showing a demonstration of Casa Systems vBNG solution, highlighting hierarchical quality of service feature. In today's networks, providers need to run bandwidth-hungry and time-sensitive applications and services alongside each other, each having its own set of requirements. HQoS provides this granularity for traffic management, was designed and has been used for many years in telco space, especially to optimize the distribution of bandwidth to different levels of services. Most telcos have developed a complex HQoS design, and the new technologies must support these traffic management policies. Casa's vBNG data plane offer flexible HQoS shaping and policing schemes that allow operators to deploy such granular traffic management. We support hierarchical shaping per subscriber group, and per port. The scheduling algorithms support priority-based and dynamic bandwidth sharing schemes to make sure the right traffic gets the right amount of bandwidth allocation. HQoS is seamlessly supported over IPoE, PBPoE, and L2TP access. Let us now see HQoS in action.
Hi there, my name is Omar Martinez, EMEA's SE based in Madrid. I will be showing you a demonstration about our HQoS capabilities on our virtual vBNG with a use case where some simulated subscribers will be provisioned with a symmetrical 100 megabit services. The virtual vBNG will provide the policy, HQoS, and the shaping as expected, and then we will add 2 more levels of shaping at the SVLAN and at the port level. Let's review the configuration on our lab first. We spun our virtual vBNG control plane and user plane on top of an open stack using a HQoS server with 10 gigabit interfaces, where we will hold a 10 gigabit total of aggregated iMix traffic, pushed from the test tool. This test tool is connected to a Tor switch and from the Tor switch to the server. For this use case, we choose the minimum setup for our flavors, so that is 4 virtual CPUs or threads for the control plane, where we can hold more than 50,000 subscribers sessions, and 16 virtual CPUs for the user plane, where we can support around 20 gigabit of total aggregated traffic. This is one of the possible architectures we can offer for you. In addition to OpenStack, we do span the virtual vBNG on KVM or on white box switches, in a standalone way with control plane and user plane in the same device, fully decentralized or in hybrid mode, usually control plane centralization and user plane close to the last mile. On the configuration side, we will configure a standard profile to provide 100 megabit services with burst and assign some priority to it. But it is also possible to create more advanced profile as we shown on the right side. We will use this more sophisticated configuration to describe an advanced design to the end of the demonstration. Let's jump on the demo and start the session of the 40 subscribers. As you can see in this chart, we'll show the session rate we're going to have. Even the session rate, it looks a little bit high. Actually, our solution can manage more than 1,000 subscriber session per second per upstream. So as you can see, all the 40 subscribers are connected on a 1,000 session rate. Well, let's check those out. You can see we have 40 subscribers on the billion range 2000 to 2099. But actually, all our subscribers will be on the SVLAN 2000 while they are using a unique CVLAN. More detail can be appreciated here, where we can see the username, the gateway IP addresses, the IP addresses assigned, the MAC address, and many other values. You have a more brief information. You can also check all the information here. So in here we have the MAC address information, the IP address information, the username information, the CVLAN and SVLAN information of each of them. Let's check resources. And let's check the current traffic. So the current traffic is 0. We are not pushing right now traffic. What we are doing here is having the core and the access interfaces graph. So basically we are querying SNMP from the VNG to this graph. So we can check the bandwidth we will receive from the test tool. So let's add some traffic to it. For it, we created 2 stream blocks of 5 gigabit each one. So it's going to be 5 gigabit pushing on the upstream and 5 gigabit pushing on the downstream. Now we have our subscribers. Let's apply the changes on the test tool so we can start our stream blocks. As you can see, some of the traffic will start here, and we will see the traffic also on the SNMP. So the blue line will be the traffic that comes from the test tool, while the green line is the traffic processed to the user plane. The expected bandwidth will be around 4.4 gigabit. As we created a symmetrical 100 megabit profile with burst, we will expect to see a small peak on the first seconds due to the configured burst, and then we should see the symmetric traffic stabilized on around 4.4 gigabytes. So that will be the sum of 40 subscribers having 100 megabits, which is equal to 4 gigabits, and then we will have some header coming from the Q&Q. Here in this traffic, you can see the burst acting, and then after a few seconds, we can see all the traffic being around 4 gigabits. So let's check that on our box. So the data plane 5 is receiving 5 gigabit on each direction, and then is processing the policy that we created and give it around 4.4 gigabits to the subscribers on the downstream and on the upstream side. Let's see some more stats from the CLI so we can check all subscribers and the traffic that is being received. We can see here all the subscribers is receiving 100 megabit traffic in the upstream and 100 megabit traffic on the downstream side. We can also check some specific details per subscriber. So let's get one. This is specific subscriber, we can check some more information. So as the policy name that this subscriber is receiving, the MAC address and the IP addresses, and the class. In this case, is a default class with a max subs rate of 100 megabit bandwidth and with some bursts on it. We do have information about the upstream and upstream flows, and of course we have the total bandwidth on the upstream and on the downstream that this particular subscriber is using. If we want to take some review on the policy map or the dynamic profile, we can also check that out. Here is the dynamic template we are using it, and this is the policy we are assigning for the upstream and downstream direction. So we also can review each of these policies. And we can also check the processor and the resources on the vBNG. As we can see, even if we are using shape and we are applying around 5 gigabit traffic up and down, and we are sending to our customers around 4 gigabits of traffic, we're just using a small portion on the resources. So if we check the system, as we discussed it before, we can see that the configure flavor for the control plane is 4 virtual CPUs or threads, and the flavor for the data plane is 16 virtual CPUs or threads. Now we check the subscriber level. Let's move forward to the next level, where we are going to apply shape to the SVLAN level. We can apply the shape in downstream, upstream, or in both directions, using values starting from 300 megabits per priority. In this case, I will apply 3 gigabits restrictions to both directions, so we will expect to see this shape on both graphs. Let's go into the configuration side and apply the changes. Now the changes are applied, we can see that the traffic will drop to the level we configured on those two lines. The system will use strict priority to manage the queues, but we also can use WFQ together with WRED if we want. So let's check some stats. Let's see how is our data plane doing. Now we can see that we are receiving the same traffic before on both directions, but actually we are sending less. So we are sending the configure shaping here for both directions. So we can check per subscriber stats and see how the subscriber is doing with the new shaping. We can see that the traffic now is dropped to around 75 megabits per subscriber, where in the past we used to have 100 megabits per subscriber. So this is the shaping at the SVLAN. Now we are ready to move to the third level, the pod level. In this level, we can apply a shape for upstream, downstream, or for both directions, and for some specific priorities, but will affect all the SVLANs going through that interface. For this example, I will apply a new restriction and move the traffic from 3 gigabits to 2.5 gigabits for both directions. So our subscribers on the priority 6, which in this case all the subscribers are using, we will see how the bandwidth is restricted to 2.5 gigabits. So for that, we need to jump into the interface and apply the changes. So let's do that. As expected, now the total traffic per upstream and per downstream is 2.5 gigabits. We can check the changes on the graph. So let's see how our data plane is doing. So now the data plane is still receiving the 5 gigabits, as we can see on the graph and on CLI level. But now we are just delivering to the subscribers on the upstream and on the downstream direction 2.5 gigabits. So let's see what happened at the subscriber level. So we can see the traffic now is less than 75 gigabits and it's around 65, 70 per subscriber. Let's see what happened on the resource level. Even we are using the 3 level of shaping, our resources are still being used in a very minimum way. So we still have a lot of bandwidth that eventually we can push on this box. And eventually we can enable more and more functionalities without impacting our resources. We were able to see some of the features that Casa Systems supports. We would like to show an advanced HQoS design that it can be supported in our system. For downstream services, we would like to support 4 different services in which we will prioritize and assure expedite forwarding traffic regardless of the service level that was assigned. For the best effort traffic, we will do a sub-classification in which we would like to offer an extra percentage of the configured remaining traffic whenever is that available. So in this case, different services that is being classified as best effort will have an extra percentage. For upstream, we would like to prioritize the expedite forwarding traffic and add an extension of the upstream bandwidth for the best effort traffic. With this type of configuration, we can manage the traffic in a granular way. Thank you very much.
This demo has shown Casa Systems vBNG solution with hierarchical quality of service. Casa's Axiom vBNG is the only TR459 CUPS ready Tier 1 NFV BNG solution that is available for deployment. Built from ground up as a cloud-native solution for both OpenStack and container-based cloud networks, Casa's Axiom vBNG easily addresses the greater diversity of broadband demands through a unique design that disaggregates network functions, streamlines packet flows, enables independent and dynamic scaling of control and data planes, and ultimately delivers superior throughput, accommodating both large and distributed capacity deployments. Casa Systems BNG solutions incorporate existing complex features like HQoS into a virtual environment without impact to the performance of this feature. If you would like to go through a more detailed demonstration or would like more information, please contact your Casa salesperson or contact us at www.casasystems.com. Thank you.